Hi, welcome to the Shiko Math Practice Lab, Learning Through Practicing. And in this practice set, we're going to talk about how to use a derivative to do the optimization problems. And we're going to have three videos and three different levels of the practice for the optimization problems here. So this video, we're going to talk about the level 1 optimization problem will be the easiest optimization problem. And so then we'll go over to the second video and the third videos, and then our problem will getting a little bit harder each time here. Okay, so for our optimization problems here, so for the first practice, we're going to have these 5 problems here. As you can see, those are very simple. It's just like basically it's like if you have two numbers, the differences or sum is a certain number, then I want to find the product or those things. Then the last two type of problem is like you want to find the maximum area, or you might find the minimum like the parameters. So that is what the the last two problems about. Okay, so now let's go ahead and go to our worksheets here. So our worksheets here. Okay. All right, so now let's start with our first ones here. So in this ones here, we talk about, we said, okay, so find the two numbers whose differences is 100 and whose product is minimus here, all right? So remember when we talk about the optimization problem during the lecture, we said the first things here, let's try to find what is my objective functions here. Right? So objective function is the product of the two numbers. So let's say the P is equal to what? Is equal to the XY's here, right? So what do we try to do here? We try to minimize this. Okay, so we want to find the minimum number of this. Then we say, hey, let's take a look at what is the conditions, right? So we have certain conditions. So then this ones here we said is a subject to, and so what is the differences here? So we said x minus y, the differences will be 100. This is the conditions the problem give us. So remember when we try to do the problem, then the next things here is we're going to replace one of the variable to be a function of the other one. So in here we can say, okay, so I can say x is equal to the 100 plus y, right? Okay, so after that, what do we need to do? We substitute, right? So we substitute this function to your objective function. So the product will be equal to x times y. So right now, what is my x here is 100 plus y and times y, right? So this will be 100y plus y squared. Then in order to find the minima and or the maxima, we need to take the first derivative. So we said the first derivative here will be, so 100y, this will be 100, and the y squared is what? Is 2. What is here is 2y's here, right? Okay, so now we set this one is equal to 0 and solve it. So if you set this one equal to 0, what is y is here? Y is negative 50 here, right? Okay, so if y is negative 50, then the x is equal to the 100 plus y. So what is x here? X is equal to the positive 50 here. Okay, so now for this problem, we find the two numbers here, right? So these two numbers, one is 50, one is negative 50. So when you minus 50 minus negative 50 will give you 100, and the product is negative 2500. That will give you the smallest number. Okay, so smallest value of the product. Okay, so this one's here is kind of a pretty straightforward, correct? All right, so now let's take a look at the next problems here. So the next problem is is find the two positive number whose product is 100 and whose sum is maximum. Okay, so same thing. Let's take a look at what is the objective functions here. Okay, so the objective function is I want to find the sums, right, of these two numbers, x plus y. So what is this one here? We say we want to maximize it, right? We want to have the maximum number. Now, what is the conditions? The conditions say these two positive number, the product is 100, right? That means what is xy is equal to what? Is equal to 100 here. So just the same things like we did in previous problem. The next step is try to find one variable as a function of the other one. So we say x is equal to the 100 what? 100 y here. After that, what you do, you substitute to your objective function. So the s is equal to the x plus y. So what is x here? We just replaced it. It's 100y plus y. Then, like we did before, we do the derivatives, right? So the derivative, this is 100y to the negative 1. So the derivative of this will be negative 100 y to the what? Y to the squares, right? And then what is here? This is the derivative is 1. Then we set this equal to 0. When you set this equal to 0, is y equal to the 100 of the y square. Then you can solve it. Y squared is equal to the 100. So I know the y is equal to the 10 or y equal to the negative 10, right? And but in here, because they say it's too positive, so y cannot be the negative 10. So y will just be the positive 10. Okay, if y equal to the positive 10, then what is the x? We substitute back to this condition. X equal to 100 over y. So it's 100 over what? It's over 10. So this is a 10. Okay, so now I find the two positive values here, and both are, both like x and y. So this is x equal to 10, y equal to 10, and the product, will give you a maximum product, right? I'm sorry, the maximum sum. So the sum will be what is plus 10 plus 10 is 20. See here, will give you the maximum sum here. Okay, all right. So now let's take a look at the next province here. The next province here will tell you the sum of the two positive number is 16. What is the smallest possible value of the sum of their square? All right, so let's take a look. So the objective is here is the sum of the square. All right, so I said the sum of the square is x squared plus y squared here. So what do we want these ones here? We want to minimize, right? We want the minimum numbers of these ones here. And what is the condition they give us? Okay, so let's say the two positive number, that means x what? X plus y equal to what here? It will be, so I'm sorry, here's right here. So it will be x plus y will be equal to the 16. Okay, so this one here is not too complicated neither. So now we can say x equal to 16 minus y here. Okay, so now you plug back into your objective function. So the sum is equal to the 16 minus y to the square plus y squares, right? And then you will set here, you will set s prime here, take the derivative. So this is the power rule. So it's 16 minus y. Don't forget what you need to do here, the chain rules, right? Okay, so you do the chain rule, and then this is 2y. Then you set this equal to 0, and then you will see, then you will say 2 of the 16 minus y is equal to 2y. So you can cancel the 2's here, right? Okay, so after you cancel the 2 here, so you will get a 16 minus y equal to y. So you will get a 16 equal to 2y. So y equal to what? Y equal to 8. Okay, so the y equal to 8, and now you plug into the x equal to the 16 minus 8, right? So x equal to what? X equal to 8 also. Okay, so what is the sum here? The sum will just be the a to the square plus a to the square is 120 what? 128 here, right? So the, you know, while we said this will give you the minima, the smallest possible value sum here. While ago, you know, in here, if you want, you can, you know, you can take a look here, right? So you can say when y equal to 8 is really, is, you know, the, you know, will give my objective function is the minima here. You can do like the derivative plot we did before. So S primes here. So we solve y equal to 8, right? So this is 8. So you choose anything less than, you know, you choose anything less than 8, and then you see the f prime, the S prime is positive or negative, right? So if you choose y equal to 0, so this is 0, so this is 0 minus 0, you know, 16 minus 0 times negative 2, so it's a negative number. So if it's a negative number, then what happened to your function here is what? It's decreasing, right? Okay, so it's decreasing, and then you choose any number greater than, you know, the 8. So if you choose 10s here, right? So this is will be 16 minus 10. It's 6 times 2 is negative 12, right? Then plus 20. So this one is positive. So what's that mean? That means that this will be increasing. So that's why when the y equal to 8, you're going to have a minimum, right? That's what is local means here. Okay, all right. So the first three are all related to the you know, give you the numbers, say the sum, product, and differences. Those is then you will find the max or min. Okay, so the next one, next two problems also is pretty simple. Is related to the area and the perimeters, those things. Okay, so let's take a look at number 4. They say find the dimensions of a rectangle with a perimeter is 100 meters and whose area is as large as possible, right? So, okay, so this is my rectangles here, right? So this is my X and Y. So what is my objective functions here? My objective function, I want to find the areas, right? So area is what? Area is X times what? X times Y, right? What do we want to do that is as large as possible. So we want to have find the maximum value. And now the next things here is what is the condition the problem give us. So let's say the perimeter is 100 meters. So if this is X and this is Y, that means 2X plus 2Y is equal to what? Is equal to hundreds, right? The perimeters here. So that means you can simplify a little bit. So it's X plus Y is equal to what? It's equal to 50. Now you set your problem up and it's a very simple problem. So you can replace the one variable with the other one. So like, you know, like we did before, right? So I just, so this is not 50. I need to be careful though. Okay, so it will be 50 minus what? 50 minus what here, right? Okay, now you plug in the areas here is X times Y. So it's 50 minus Y times y, right? So this is 50y minus y squared by distributive property. Then what I need to do? The derivative. So the derivative, this is 50, and then minus y squared is what? Is 2y. So set equal to 0. Now, what is the y? Y is 25 here. Okay, then we know the x is equal to the 50 minus y. So it's 50 minus 25. So x is equal to what? Is equal to 25 here. So this rectangle turns out to be what is really is a squares, right? Because x equal to 25, y equal to 25, right? So it's in fact it's a square. So what is the areas here? Area will just be 25 times 25. So it's 625. This is the largest area you're going to have with the perimeter is hundreds here. Okay, so as long as you draw a picture and then you find your objective function, your conditions, and then I think you will be able to solve it. It's pretty easy. Okay, so now let's take a look here. So this one is kind of like the backward about the other one. The other one give you the perimeters, and then once you find the area. So right now this one is give you the areas, right? So here let's say, okay, so this is my rectangle XY here, and we want to find the perimeters as small as possible. So my objective function. Okay, my objective function is the perimeters here is like a what? 2 times x plus y, right? Because there's 4 sides. And okay, let's take a look at what is the conditions here. The area is thousands, right? That means what? X times y is equal to what? X times y is equal to 1,000. So then this problem, the objective function and the conditions are pretty, it's pretty easy. So just like we did before, change the one variable to be the function of the other one. So x will be 1,000 divided by y. All right, then substitute to my objective function. So it's p. So this is 2. So it's 1,000, the y plus what? Y's here. All right. And now let's take a look at the derivative p prime. So this 2 still here. Then the 1,000 over 1 over y. 1 over y is y to the negative 1. So you take the negative 1 out. So this is negative 2. Then negative 1 minus 1 is negative 2. So here is 2, right? So this is 1,000, correct? Okay. So this is 1,000 and plus, this is y. Don't forget to have 2 in front. It's a 2, right? So then we set this equal to 0. And then you can cancel the 2 both sides. And then you can say the 1,000 y squared is equal to 1. Okay, so the 1,000 y squared is equal to 1. So what you can get here? So you will get the y squared is equal to what? It's 1,000. So what is the y? So y will be the square roots of the 1,000, right? Because I cannot have negative, so it's 1,000. Okay, so now the x here, x is 1,000 over y. So it's 1,000 over square roots of the 1,000. So what is here? X is 1,000. Okay, y is 1,000. So that's why, so we will get a minimum perimeter. So it's another one is a squares, right? So that means x equal to the square root of 1,000, y equal to the square root of 1,000. So what is the perimeters here? So it's 2 times x plus y. So it will be 4 over square roots of the 1,000, right? Because this is square roots of 1,000. This is square roots of 1,000 here. Okay, and that's it. That is the level 1 optimization problems. And we did 5 problems as the practice. As you can see, the level 1 problems really, they are very, very straightforward and simple problems here. All right. Okay. That's it. And looking forward to talk to you in our next level, level number 2 here. Okay, talk to you later. Okay, bye bye.